Hello everyone, welcome to this course on OCI Object Storage Service. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this module, we'll describe concepts, use cases, and different tiers and features of Object Storage Service. And then we'll look into a quick demo of how you can manage the object storage buckets and objects. Before we dive deeper into the OCI object storage service, let's look at where it fits within the realm of the wider portfolio of OCI storage services. So as you can see here, object storage is the storage for the web. It's highly durable object storage. Highly durable means we manage and maintain multiple copies across ADs. So we make a few copies in a AD, and we do that for at least 2 different ADs within a region. So multiple copies across ADs. The scale is in petabytes. For the unit size, the object can be up to 10 terabyte in size, and it's storage for the web. So it's basically useful for unstructured data, so things like logs, images, videos, etc. This is the storage you would typically use. Now a kind of a tier of the object storage is archive storage, and archive storage is good for long-term archival and backup. So if you have data which you want to archive, you could use the archival storage. Like object storage, it's highly durable, meaning we maintain multiple copies across AD. The scale can be in petabytes. The maximum size of the object we support is 10 terabyte per object, and the use case here is long-term archival and backups. So a good use case can be Oracle database backups, right? If you have a lot of backups, you want to keep them in somewhere in a very cost efficient manner, in a very reliable manner, you could use the archival storage. Now, what are the characteristics of the object storage service? So this is internet scale storage for the web, high performance storage platform. It's ideal for storing unlimited amount of unstructured data. So any data like image, media files, logs, backups, it's a good those kind of storage data you could use to store in the object storage service. Data is managed as objects using APIs built on standard HTTP verbs, so get and put, etc. It's a regional service. Keep in mind that it's not tied to any specific compute instance. So for example, you don't format object storage, you don't put an operating system on it, right? Because this is not a block volumes. Object storage is an internet scale high performance storage platform for the web to store unlimited amount of unstructured data. There are 2 distinct storage classes to address the need for performant, frequently accessed hot storage and less frequently accessed cold storage. And we talked about this in the previous slide. You have object storage itself, and you also have archival storage, which is this less frequently cold storage tier. It supports private access from Oracle Cloud Infrastructure resources in a VCN through a service gateway. We covered this as part of our VCN course, but if you have a need, for example, to store your database backups to object storage, you could use something called service gateway. In that case, you are not really sending your traffic through the public internet. You are traversing the traffic through the Oracle backbone, and you can still access OCI public services like object storage for backups. OCI Object Storage Service supports additional advanced features such as cross-region copy, pre-authenticated request, and lifecycle management rules, and multi-part upload. We will look into each of these characteristics subsequently in this course. So what are the scenarios for object storage? The first scenario, as we discussed earlier, this is good for unstructured, unlimited amount of unstructured data as a content repository. So you can have you can store data, images, logs, videos, whatnot, in object storage. You can also use object storage for archive and backup. So if you have a need to preserve data for longer periods of time, you could store them in object storage. You could use it, of course, for things like log data, massive amounts of logs. You could store it in object storage. You could use it for big data, IoT kind of large data sets, workloads, Hadoop workloads, and then those are the main use cases. There are many other use cases where you would use object storage, but these are some of the big ones where object storage would be a good fit. Now, what are the features of the object storage service? The first feature is thing called strong consistency. So strong consistency means that when you create an object and you update it and you try to read it back, you always get the latest copy. You always get the most recent copy of the data when you retrieve it. The contrast to strong consistency is eventual consistency, where eventually the data will be the most up to date. We support strong consistency, and there are a lot of trade-offs you have to go through to get to strong consistency. But this is something which is makes your life easier as developers, because you don't have to worry about the nuances of eventual consistency. The data is highly durable. Data is stored redundantly across multiple storage servers, across multiple ADs, and data integrity is actively monitored and corrupt data detected and auto repaired. Performance is actually pretty good. We make sure that the object storage service can ingest many GBps of data, or even higher, right? So that's all built into the service. You can define your own custom metadata, and we use server-side encryption to encrypt object data. You can also bring in your own keys to encrypt your objects, but if you decide not to do that, we have by default encryption at rest for the object data. So let's look at some of the basics for the object storage service. So first is the object. Object is basically all the data regardless of content type. So it's logs, videos, text, whatever it is, you basically call that as an object. Each object is composed of object itself and the metadata of the object. A bucket is a logical container for storing objects, right? So each object gets stored in a bucket, and we have this thing called a namespace. A namespace is a logical entity that serves as a top level container for all buckets and objects. Each tenancy is provided with one unique namespace that is global, spanning all compartments and regions. So this is the constraint you have to live with. You have this one unique namespace, and all your buckets and objects go into that namespace. Bucket names must be unique within your tenancy, but can be repeated across tenancies. So for example, if you create a bucket called Oracle, I could have that in my namespace in my tenancy, and somebody else could also have a bucket called Oracle in their tenancy. Now if you go to a competing service like Amazon S3, the bucket names have to be globally unique. So if two people create a bucket called Oracle, it is not supported. You cannot do that, right? So you have to have it globally unique bucket names. In case of OCI, bucket names have to be unique within your own namespace, within your tenancy, but can be repeated across other namespaces, across other tenancies. Within the namespace, bucket and objects exist in flat hierarchy, but you can simulate a directory structure using prefixes and hierarchies, and we'll look into how you do this subsequently. So what are the two tiers we talked about at the beginning? So the first tier is called the hot tier, the standard storage tier. This is for fast, immediate, and frequent access. Object storage service always serves the most recent copy of the data when retrieved. Data retrieval is instantaneous, and standard buckets cannot be downgraded to a cold tier or an archive storage. On the other hand, the archive storage tier, also called as the cold tier, is for data which is seldom or rarely accessed but must be retained and preserved for long periods of time. So think about your your long-term archival and backup. Minimum retention requirement for archive storage is 90 days, and if you get your data retrieved before 90 days, you actually pay a penalty. Objects need to be restored before you download them from archival storage, and like standard buckets, archive buckets cannot be upgraded to standard storage tier. So when you are creating these buckets, you get a choice here which says standard or archive. Just choose it carefully, because later on you cannot change them. You can always start from scratch, but just keep that in mind. The time to first byte in case of archival storage restore is 4 hours. So keep that again in mind. If you want to restore data from your archive storage, there is a minimum amount of time before you start getting your data back. So how does object naming work in case of OCI? So the service prepends the object storage namespace string and bucket names to object names, right? So let's look at this example. So you have /n here, and this is your namespace. In most of the cases, this is the same as your tenancy. And right here is the bucket. This is your bucket name, the one you choose. And right here is object, the object name you choose, right? So this would be constructed something like this. So you have the whole endpoint here, object storage.usphoenix1.oraclecloud.com. This is my endpoint where my service is running. And right here I have this tenancy, GSE something. I have this bucket, database backup, and I have this database file here as my object. So keep in mind, this is how the object name is. If when you go try to if you try to get that URL, this is how the URL will be constructed for the object name. Now we talked about the fact that object storage has a flat hierarchy, but for large number of objects you could use prefixes and hierarchy. So what does that mean? So look at the two example here. We have the same namespace. It's the same tenancy, and we have the same bucket, event photos, right? But now we can use something like /marathon/ this finish line. There is an object here, and we could say /marathon/ participants / some object here, right? So we can use the CLI to perform bulk downloads and bulk delete of all objects at a specified level hierarchy without affecting objects in level above or below. So for example, above you can use the CLI to download or delete all objects at the marathon level without downloading or deleting objects at the marathon participants level. So if we just want to operate on this but not operate on this one, I could actually use I could run a command to delete objects at this level, but that would not impact my objects at this particular sub level, right? So I could do those kind of I could create sort of a false notion of a hierarchy for some of the bulk operations on my objects. There's a feature called cross-region copy, and as the name specifies, it lets you copy objects to other buckets in the same region and to buckets in other regions, right? So this is a very handy feature if you have sort of a global operation, you want to use other regions, you want to move your data around, or within the same region itself, if you want to copy data, the cross-region copy is a very handy feature. And it's very straightforward here, right? You provide the destination namespace, you provide the destination region, and you provide the destination bucket, and then you have certain design considerations, and your object would be copy. Now before you make use of this feature, you must authorize the service to manage objects on your behalf. So you need to write this policy. If you don't do this policy, you would not be able to copy your data across regions, for example, right? So if you have to write this policy, I have written this for Ashburn. If I was copying to Phoenix, I would have to write the same policy for Phoenix. You must specify an existing target bucket. This cannot be empty. And today you cannot do bulk copying, so you have to copy one by one. There is no way for you to copy many objects at the same time, and you cannot copy from archive storage. So those are some of the design considerations to keep in mind as you work on cross-region copy requirements. There is something called object lifecycle management, and it basically defines lifecycle rules to automatically archive or delete objects after a specified number of days. So like the cross region copy for objects, you must authorize the service to manage objects on your behalf. So right here you write a policy saying that, I'm authorizing the service to manage objects on my behalf. And once you written the policy, you could create your lifecycle rules. It's very simple. You create using this is very simple. You provide the name here. You say what is my lifecycle action. Is it delete or is it archive? How many days threshold before I delete or archive? And then that's pretty much it. It's applied at the bucket or object name prefix level. If no prefix is specified, the rule will apply to all objects in the bucket. So you could specify the prefix right here. So for example, if you have a prefix like hierarchy like this, name like this, the one in green here, this right here is your prefix, right? So you could use a prefix like this to either do one object at a time, or you could do apply the rule to all the objects in the bucket. The rule that deletes an object will always takes priority over a rule that would archive the same object. So remember, if you have a conflicting rule, the rule on delete always takes precedence over the rule on archive. You can enable or disable a rule to make it active or inactive. So you could actually change right here, and you could make a rule either active or inactive. There is something called pre-authenticated request. It provides a way to let users access a bucket or an object without having their own credentials. So as you know, you can make your buckets public or private. If your buckets are private, how do you let other users, or if you want to make it private but you want to give access to users, you could use something called pre-authenticated request, using which users can access a bucket or an object without having their own credentials, right? So for example, right here I am showing you how you create a pre-authenticated request. This is my I'm creating this for my particular object, and I'm saying I have different options. I am permitting reads on the object. I could do permit writes on the object, or I could do read or write on the object, right? And when I click on this create pre-authenticated request here, it constructs a long URL for me, and I could give this URL to users, and they could access this object. The advantage here is I can revoke the links anytime. So if for example, if I want to share this private object in a very secure fashion, only the people whom I have given this URL know it and access it. At any time I can come in, and I can also revoke the links. So if I feel that it has been breached, or I don't no longer want to share it with users, I can always revoke the links at any given time. On the contrary, if you don't want to have private buckets, you can always create public buckets. At creation, a bucket is always considered private, and access to the bucket requires authentication and authorization, but I can change it, right? I can make it public, and public basically means it's anonymous, unauthenticated access to the bucket, and anyone can read from that bucket. Changing the type of access doesn't affect existing pre-authenticated request. Existing pre-authenticated requests still work, so you could still make it from private to public, and your pre-authenticated request will still work. There is something called a multi-part upload. With multi-part uploads, individual parts of an object can be uploaded in parallel to reduce the amount of time you spend uploading the object, right? So there are various steps involved. The 4 steps involved in multi-part upload. So the first thing is you create your object parts. So you would do a multi-part upload to upload objects larger than 100 MB. You would not use it for a very small data set, right? For example, a small object. Individual parts can be as large as 50 gigs or as small as 10 MB. And you assign your part numbers to these object parts, and the part numbers go from 1 to 10,000. So you cannot randomly choose numbers something like 50,000. So that's step one. Step two is to initiate an upload. So you can initiate an upload by using this REST API call. You could use the CLI. The third part is uploading the parts. So at this point you are in essence you are uploading the parts, and if you have network issues you can restart a failed upload for an individual part. You do not need to restart the entire upload process. And then the last and the final step is to commit the upload. So when you have uploaded all the object parts, you can complete the multi-part upload by committing it and adding things like checksum, etc., to make sure that your object integrity is maintained, and it's the object is the object you uploaded is the object you get in OCI. We looked into Service Gateway in the Virtual Cloud Network course. Service Gateway lets resources in VCN access public services such as object storage, but without using an internet or NAT gateway. So for here you have a database, and it wants to go to the object storage for backup purposes. So you could use a service gateway, and using that traffic from VCN that is destined from one of the supported OCI public services such as object storage uses the instance's private IP address for routing, travels over OCI network fabric, and never traverses the internet. So the use case here would be backing up your database systems in VCN to object storage. This is a really handy feature for use cases where you're running your own databases in OCI and you want to back them up to object storage. So now let's look at a few demos on object storage service. So I'll switch over to my console. We have been using this compartment called training for all our courses. So we will use the same compartment for object storage service as well. You can see here I'm in the training compartment and in Ashburn region, and I have no buckets here. So the first thing I'm going to do is I'm going to create a bucket. So let me click on create bucket. It's asking me for a bucket name, and I can say this is my bucket for pictures. And it's asking whether it's a standard bucket or an archive bucket. Let's go with standard, and we'll talk about archive later on. There's also an option to use encryption with key management. So I can click here, and in this particular account I don't have key management service available, but if I had it available, I could create a vault here and I could keep my own keys here, master encryption keys, and using that I could have encrypted my objects. Now object storage, as we saw on the slides, has a default server-side encryption enabled, but the keys are controlled by Oracle. If you don't want that option, you can always come in here and you can provide your own keys, and we would encrypt your objects using your own customer provided keys. So right now I create this bucket called pictures. It's a standard tier, and click create, and that's pretty much it. The bucket is created. I can click on this ellipsis, and I can do a bunch of things, right? I can create a pre-authenticated request. We'll look into that. I can change my compartment. Now remember, the only resources or objects which let you do that are buckets. If you create a compute instance, you cannot change your compartment, right? A block volume or VCN, etc. But with buckets you can actually change the compartments. I can do tagging, etc. So first thing I'll see here is if I come here, I can see the buckets by default are created as private, which means that it's not available for unauthenticated anonymous access. So anyone who goes and gets this bucket cannot do anything with this, right? So it's a private bucket. Now I can change it. I can click on this update visibility and I can make it public, and then what it means is the objects I upload can be available with an unauthenticated anonymous request. But let's do a couple of things here. So first thing I'm going to do is I'm going to upload objects. So I click on upload object, and it's a very simple UI. It says you can upload an object console to upload objects up to 2 gig in size. Now if you need more bigger objects than that, then you can use the CLI to do things like multi-part upload. We looked into that when we were going over slides. If you have larger objects, pretty much, you would not use the console to upload them, but you will use multi-part upload. So I have downloaded a picture here, which is the Oracle Cloud Infrastructure logo, and I'll just click upload here. And there you go, my object is now available in this bucket. Now if I click on details, this is how my object URL is constructed. If you remember, the first part is my storage endpoint, the service endpoint. I'm running in Ashburn region, so it goes something like object storage dot region us-ashburn-1 .oraclecloud.com. If it was Phoenix, you would replace Ashburn with Phoenix, and so on and so forth. Then there is my tenancy name. Remember, this is my account. Then there is the bucket name. This is the pictures bucket, and then there is the object name, OCI block features.jpg, right? So that's how the URL is constructed for an object in OCI object storage service. Now if I paste that that URL in my browser, it says that the bucket doesn't exist, or you're not authorized to access it. We are not authorized, of course, because the visibility here is private. Now, as I said, I can come here and I can change that to public, and when I do that and I go back to my URL, I can see that there is a picture here, right, which is Oracle Cloud Infrastructure, just the logo there. Now I could do a bunch of things here. One thing I could do is I can change back the visibility to private, and I could create this thing called pre-authenticated request. We talked about this when we were discussing the features and the capabilities. And what this thing does is you can for all practical purposes, unless you have a need like that, you will not have objects existing in public buckets, right? Because that can be a security issue. For some use cases where you have a white paper, or you have content which you want to publicly which you want to make available publicly, that's fine. But for other purposes, you would have buckets which would be private. So what you can do is, if you still want your users to have access to certain objects or certain buckets, you can create these pre-authenticated requests, and using these you are providing a URL which you provide to your users, so they have access to the URL. You can revoke the links anytime, and the advantage with this approach is only the users who have access to that URL can download the object or use the object. Nobody else can do that. So I would say I'm creating a pre-authenticated request for this particular object. You can do it on a bucket level, or you could do it on an object level, right? So in this case, I'm doing it at the object level, and you could specify what kind of access you want to give. Either it's read, it's write, or it's read and write both. And you can also set an expiration date after which the URL will not work. So in this case, I'm giving 7th December. You could do for a much longer period as well. And I click on pre-authenticated request here. Now this URL gets created. I have to keep this in my record, because as you see here, this is not going to be shown again, right? So if I go back to my we had this object, and I change back the visibility to private. So if I click refresh here, I should not be able to view this object, right? So if I do that, you can see that this object doesn't exist anymore, right? It says you are not authorized to access it. So let me get this URL now. And when I go and open another tab and I provide this URL, now because it's a private bucket, but I have created a pre-authenticated request. So using this URL, my users can access that particular object. So if I click that, now you can see that I can access this object, right? So this is one of the mechanisms where you can still manage your security, but at the same time you can give access to your objects and buckets to users. Now you can revoke this link anytime, right? You can come in here and you say that you don't want this link to be available anymore. So you can see this pre-authenticated request is created. If I delete this, the pre-authenticated request is not valid anymore, and if I click on refresh this URL, it says this is not valid, right? I cannot access the object anymore. So very nice feature on how you can use still use private resources, but give access to users for if you have needs purposes like that. So let's look at some other capabilities. The other things you can do here is you can copy objects, right? We talked about this earlier. So right now I'm in Ashburn region, and first thing I'm going to do is let me create a bucket in Phoenix region. So I have this is my Phoenix region. It's the same compartment. I say create a bucket, and I say let's create a pictures bucket in Phoenix, and so I'll give the same name. I'll say it's Phoenix PHX, and it's a standard tier is fine, and I create this bucket. So first thing is I have this bucket created here, right? Now the next thing I need to do is, before I copy objects, I need to have my policies set up. So if I go to policies here, I can see that if I go to my training compartment, there is no policy. But if I go to the root compartment, I can see that there is a policy for object storage to manage objects in tenancy. So my Ashburn, my this particular region, this particular endpoint can manage objects family in tenancy, meaning all my compartments. If I didn't have this policy, if I wanted to do a compartment specific policy, I would replace this with, say, in compartment training, right? So I could have done that. Because this policy exists, I don't need to write it again, because it's applicable. Remember, the policies have inheritance built in, so it's applicable at the tenancy level. I don't need to write a policy specifically at the compartment level. So if I go back to my object storage, I'm going to copy an object from Ashburn to Phoenix. This is really interesting for scenarios like disaster recovery, where you have data existing in one region and something goes wrong with that region. You can always move the data to another region. So this is part of the DR strategy. So let me go back to my training compartment. I have one object here, one bucket and one object, and right here if I click on this, you can see that there is an option which says copy. Let me just scroll this. I'm working on a really small real estate here. So there is something called copy. So I click on that, and as you can see here, it says my namespace is the same. I can actually copy between different namespaces, but this case, my destination namespace is the same as my origination namespace. I'm same account. I can choose a region. I say Phoenix, and then it says destination bucket. Unfortunately, today it doesn't give me a drop down, so I need to know what is the name of the bucket in which I'm going to copy my object to. So this is the bucket we just created, and right here I have multiple options. I can overwrite. I can there's an option not to overwrite if there is an existing object like that, and so on and so forth, right? There's more advanced capabilities there. So I click copy, and what you will see is within a few seconds my object would be copied to my destination region, right? So it says completed, and if I click here, I can see that there is a work request which says that the copy of object from Ashburn to Phoenix has been done, and you can see here the start time, the finish time, etc., right? So if I go to my Phoenix region, I can see that my object is available here, right? And if I click on the details, and you can see the visibility is private here. Let me just change that to public, save this, and now if I go to my details, now see the URL is changed. It's not Ashburn anymore, it's Phoenix, right? Because that's my endpoint in this region, object storage endpoint. And if I click I bring up this link in my URL in my browser, I can see the object is now existing in the Phoenix region, not in Ashburn anymore, right? So this is a really nice, interesting feature for scenarios where you want to do disaster recovery. Let me switch back to Ashburn region, and I have my bucket here and my object. Last thing I want to show is the lifecycle policy rules. So we discussed this in our content as well. If I click create rule, I can create lifecycle rules to either delete the object or archive the object. And I can make it more complex by using things like object name, prefix, etc., right? So I'll say this is my first rule, and I want to delete my objects after 7 days. It can be, it as the text says here, delete objects that are older than 7 days and that match any of the specified object name prefixes. So I could actually put some prefixes here, and whether the status is enabled or disabled, and create this rule. And now what will happen is after 7 days, any object which has a lifespan of more than 7 days in this bucket will get deleted. I can always disable this rule, and I could have done things like I could have archived the object as well, right? So these are the three features I wanted to discuss: pre-authenticated request, multi-region copy, cross-region copy, and then lifecycle policy rules. Now there is one last thing I want to show here, which is the archive bucket. So if I click on create bucket now, the two options I get is standard and archive. So let's say I want to create a bucket, but now I want to archive my pictures there, right? So I would just choose archive and I'll create bucket. It's very simple. Same process as creating a standard bucket. I can upload an object. Let me upload the same object which we uploaded a while back. And now here I have this feature called restore object, right? So now this object is put in a bucket which is an archive bucket, right? So you would see some of these capabilities like pre-authenticated request, etc., are grayed out because they are no longer applicable because the bucket type is different. So you can see that the pre-authenticated request is grayed out, copies, multi-region, cross-region copy is grayed out because those are not applicable anymore. Now one thing I could do here is I could restore these objects. So if I click on restore object, I can provide the name for my object. So it has to be the same name as the object here. Let me just copy that. And I can specify the time available for download. That's an optional thing, but I could just click here. And now what would happen is if I click on the work request, I could see that there is a work request for restoring that object, right? Remember the first the time to the first byte is 4 hours and more, so it will take some time, but I can restore my objects from my archival bucket like that. So that's pretty much everything on object storage. I haven't shown things like multi-part upload because that's something which we will use. Typically the way to show that is through CLI. We also have a level 200 course where we dive deeper into some of the more advanced concepts. So to summarize, object storage is an internet scale high performance storage platform. It's a regional service not tied to any specific compute or block volume compute instances block volume service. It offers two distinct storage classes to address the need for performant frequently accessed storage called standard tier hot storage and less frequently accessed cold storage. Also we call them as archive buckets. Supports private access from Oracle Cloud Infrastructure resources in a VCN through a feature called Service Gateway, and supports advanced features such as cross-region copy. We saw an example of moving an object between Ashburn and Phoenix. A lifecycle management, you can either delete or archive objects after a certain period of time, and you can do things like object name prefixes. A pre-authenticated request, your objects and buckets can be private, but you can make them available to your users in a very secure fashion. And multi-part upload for objects which are bigger than a specific size such as 2 gig, up to which you can use the console. So with that, thank you very much for attending this course on object storage service. I hope this was really useful, and I look forward to seeing you in the next course on the load balancer service.